How are you doing, viewers? My name is Tutor Daniel, and today we're going to talk about matrices in mathematics. So our first question here is saying that given that the matrix A is equal to that, you are told to find the A determinant of matrix A. So how to find the determinant of matrix A? So determinant of matrix A. So how to find the determinant? We need to subtract the major diagonal and the minor diagonal. So the major diagonal is this one over here. So this is the major diagonal. Then the minor diagonal is, this is the minor diagonal. So for us to get a determinant, we need to subtract the major diagonal and the minor diagonal. So our determinant is equal to our major diagonal minus our minor diagonal. So what we need to do first, locate where your major diagonal is in the matrix that you are given. So our major diagonal here is 8 and 2 there. So I'll multiply 8 and 2. So say 8 multiplied by 2, close brackets. We subtract by our minor diagonal, which is 1 and 7 over there. So here I'll multiply 1 times 7. Then determinant is equal to 8 times 2 gets 16 minus 1 times 7 or get 7. Then when you subtract 7 from 16, you get 9. So 9 is our determinant. So how to find the determinant? You simply subtract the major diagonal and the minor diagonal. So after you subtract the major diagonal and the minor diagonal, you find your determinant over there. Then our question B over here is saying, find the inverse of matrix A. Find the inverse of matrix A. So I thought to find the inverse of matrix A. So inverse of matrix A is equal to 1 divided by the determinant multiplied by our adjacent of matrix A. So how to get our inverse? Simply divide 1 over the determinant multiplied by our matrix A. So our determinant, we had found our determinant to be 9. So what I'll simply do here, I'll say our inverse, A inverse, is equal to 1 divided by the determinant. So our determinant is 9. So 1 divided by 9 multiplied by our matrix A. So what you need to do before putting in matrix A there, so what you need to do first, you swap the values that are in the major diagonal. So here we're going to swap our 8 and our 2 there. So the major diagonal, the values that are in the major diagonal, we swap them. So here, when I swap 8 and 2, so our 2 will be on top there, and our 8 will come at the bottom. So we always swap the values that are in the major diagonal. So in the major diagonal, we swap the two values over there. So if I've got 8 and 2 there, so we'll swap the 2 like that. So, she's that. Then in the minor diagonal now, so when it comes to the minor diagonal, we always change the signs of the two values. We do not swap the two numbers over there, but we just change the signs. So if one was negative, in this case, we do turn into positive. But if they are both positive like this, they will both turn into negative. So in this case over there, so I'll say negative 7 and negative 1. Because they are both positive. This is positive 1 and positive 7 over there. So in the major diagonal, we swap the values. Then in the minor diagonal, we change the signs. So in a case where 7 was negative, so we would have written positive 7 over here. But in this case, the 7 is positive. So the opposite of a positive is simply a negative. That's why I've written negatives on both sides. So this is your final answer. So this is our inverse of matrix A. If you want, you can further on multiply the 1 over 9 times that, but you can simply leave your answer as that. Then we move to our example 2. Example 2 states that given that matrix A is equal to 8, 1, x, and 2, find the value of x given that the determinant of matrix A is 9. So in this case, we're already given the determinant. So the formula that you use whenever you're given the determinant already. So I'll say determinant is equal to our major diagonal minus our minor diagonal. So our determinant is always equal to our major diagonal and we subtract it by our minor diagonal. So in this case, the major diagonal over here is where 8 and 2 lie there. That's our major diagonal. And our minor diagonal is where we have positive 1 and x over there. So what we'll simply do, our determinant is already given in this case. So what is d there, I'll replace 9. So I'll say 9 is equal to, then our major diagonal. So our major diagonal is 8 multiplied by 2. So I'll say 8 times 2, close brackets, minus, then our minor diagonal. Our minor diagonal is where 1 and x lie. So I'll say 1 times x. So in this case, now I'll later on simplify. So 8 times 2 is 16. Then minus 1 times x is simply x. Then x times positive x times negative 1 is simply negative x. So when I reach this stage now, I'll simply group the like terms together. When I reach this stage, I'll simply group the like terms together. So I'll take positive 16 to the other side. So I'll say 9 minus, because this 16 is positive, and when it crosses the equal sign, it becomes negative. So 9 minus 16 is equal to negative x. So in this case, I'll subtract this. So when I subtract 9 and 16, I'll simply get negative 7. So negative 7 is equal to negative x. And since I've got negatives on both sides over here, I'll simply divide by negative 1 throughout. So the negative and the negative will cancel each other, we get a positive, and the negative there, negative will cancel each other, we get a positive. So our value of x over here is equal to 7. So whenever I given the determinant already and the matrix there, you're told to find any of the values there. So what you do first, you use this equation over there. So I'll say our determinant is equal to our major diagonal minus our minor diagonal. So the major diagonal is where 8 and 2 lies, and our minor diagonal is where positive 1 and x lie over there. So you simply work out that. Thank you.